Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the setback distances. Setback distance is the distance from the center of the horizontal curve to an obstruction on the inner side of the curve. And in the design of the horizontal alignment, the side distance along the inner side of the curve should be considered. Where there are the side obstructions like the buildings, cut slopes or trees on the inner side of the curve, either the obstruction should be removed or the alignment should be changed in order to provide adequate side distance. It may sometimes be possible to make some adjustments in the normal highway cross section to make up small deficiencies in the side distances. If it is not possible to provide the adequate side distance on the curve on the existing roads, regulatory and cautionary signs should be installed in order to control the traffic suitably. In case of the new highways, for the design speed and the distance requirements, the actual condition in the alignment should be checked and necessary adjustments should be made in a manner most fitting to provide adequate side distances. On the narrow road, the side distance is measured along the center line of the road, whereas on the wide roads, the side distance is measured along the center line of the inner side lane. Thus, the side distance it depends upon the following factors. First, the required side distance S, the radius of the horizontal curve R, and the length of the curve LC, which may be greater or lesser than the S. So if you just observe the figure, here we have the radius of the horizontal curve R, then the required side distance S from the point A to point B, and M is the required setback which has to be provided in order to have a clear vision from point A to point B on a horizontal curve in order to avoid the accidents. Now the analysis of the setback distances. The two cases are considered for the analysis. First, when the length of the curve is more than the side distance, that is LC is greater than S, and second case when the length of the curve is less than the side distance, that is LS is less than S. The LC, is less than S. So the first case, when the length of the curve is greater than the required side distance. So for a narrow road, let the length of the curve LC be greater than that of the side distance S. Then the angle subtended by the arc length S at the center be alpha. On the narrow road, such as single lane roads, the side distance is measured along the center line of the road, and the angle subtended at the center alpha is equal to S upon R radians. Therefore, the half central angle will be given as alpha by 2, which will be equals to S upon 2R in radians, that equals to 180 S upon 2 pi R in degrees. And the distance from the obstruction to the center R cos alpha by 2. Therefore, the setback distance M required for the center line is given by M equals to R minus R into cos alpha by 2. As you can see from the figure, M is the setback distance with the angle made alpha by the circular curve. In case of the wide roads with 2 or more lanes, if D is the distance between the center line of the road and the center line of the inner side lane in meter, the side distance is measured along the middle of the inner lane, and the setback distance M is given as m equals to r minus in the bracket r minus d cos alpha by 2, where alpha by 2 equals to 180 s upon 2 pi in the bracket r minus d in degrees, and alpha by 2 equals to s upon 2 in the bracket r minus d in radians, where alpha is the angle subtended by the arc, m is the setback distance in meters, r is the radius of the curve in meters, s is the side distance in meters, and d is the distance between the center line of the road and the center line of the inner lane. When the length of the curve is less than the required side distance. For the narrow road, if the side distance required is greater than the length of the curve LC, then the angle alpha subtended at the center is determined with reference to the length of the circular curve. LC and setback distance is calculated out in two parts as given below. Alpha by 2 equals to LC upon 2 pi r in radians, or alpha by 2 equals to 180 into LC upon 2 pi r in degrees. And the setback distance m for a narrow road is given by m equals to r minus r cos alpha by 2 plus s minus LC by 2 into sin alpha by 2. The clearance of the obstruction up to the setback distance is important where there is a cut slope in the inner side of the horizontal curve. As you can see from the figure, here we have the setback distances m1 and m2 which togetherly conjugate to have the total setback distance of m, and the length of the curve L is less than the required side distance S. R is the radius of the curve. For a wider road, alpha by 2 equals to LC upon 2 into R minus D in radians, and alpha by 2 equals to 180 into LC upon 2 pi into R minus D in degrees. So the setback distance in meters for a wide road is given by m equals to R minus in the bracket R minus D cos alpha by 2 plus S minus LC upon 2 into sin alpha by 2. With this we shall stop here. Thank you.